Let's consider the word disaster. We all know its meaning of misfortune, calamity, and even more, of various serious sudden damage. And it is certainly singular that the word derives from a term that in ancient Greek means bad star. How many times life on the planet has been affected by such disastrous events to the point of causing episodes of mass extinction of living beings? Is it possible that a bad star really exists near the sun and that periodically it triggers extinction phenomena? 36 years have passed since the publication on Nature number 308 of April 19, 1984 of the article Extinction of Species by Periodic Comet Showers, from which was born the myth and the fascination of Nemesis, the Death Star. What's left of that hypothesis? Full of twists and turns, interminable as a soap opera, exciting more than a detective story. It is the story of biological mass extinctions, including the famous disappearance of dinosaurs at the end of the Cretaceous period, and the consequent search for what may have caused them. No doubt about the actual perpetrator, who's been spotted, but who's behind this? As already mentioned, the various events that characterize the story that we are about to tell you are not very different from those of a real detective story. We will use this analogy to outline the sequence of events. Everything begins with the discovery of a corpse, the extinction of the dinosaurs, which occurred 66 million years ago. The few clues available suggest that it is a crime, and the investigation seems to converge towards a possible culprit, an asteroid, as scientists Luis and Walter Alvarez, father and son, will prove in the 70s. Case solved? Absolutely not. Further research leads to the classic twist. The crime may not be an isolated event, but part of a precise and planned chain of crime. Biological extinctions, in fact, are repeated periodically. In that case, it is obvious to think that there is a real organization that holds the thread of the skein. In that case, it would not be enough to look for the material executors, be they asteroids or comets, but it would be necessary to arrive up to the principals, and here the investigations become really difficult. Unfortunately, we have not yet found a new Sherlock Holmes able to unravel the tangled skein. We have to be content with the hypotheses that are still far from defining a completely logical and unassailable picture. Let's take a look at the dossier, analyzing the clues and the various conjectures advanced to justify them. The culprit, as we have already said, seemed to be unmasked, an asteroid of the NEO, Near-Earth Object Group. These small bodies have, in fact, the unpleasant prerogative of moving on orbits intersecting that of the Earth. Based on their number, estimated today with sufficient accuracy, it can be established that an impact between our planet and an object of about 10 kilometers in diameter is statistically predictable on average every 100 million years. So let's reconstruct the facts. An object of about 10 kilometers in diameter falls to Earth at a speed of a few tens of kilometers per second. Most likely it ends up in some ocean, raising a wave more than a kilometer high. This propagates at incredible speed, hitting the land and pushing inside them for hundreds of kilometers. The dust raised by the impact quickly reaches the atmospheric layers and in a short time envelops our planet in a dark veil, impenetrable to sunlight. Night and frost fall on the globe. Plants die, animals less resistant or less accustomed to precarious living conditions succumb quickly. The various food chains break or undergo uncontrollable and irreversible changes. When after a few months or a few years, the dust settles on the ground, the sun returns to illuminate a world completely upset and unrecognizable. The crime of 66 million years ago has thus been solved, but much work remains to be done. The Cretaceous extinction, in fact, was certainly not the only one. There were others, and this has been known since the 19th century. The first to hypothesize it very vaguely was in 1825, the French biologist Georges Cuvier. Then, with the process of geology, a more and more accurate dating of the rocks was achieved, and the extinction episodes started to find a more and more precise collocation in the past. The chronology of the Earth's history became a refined science. The geological eras were defined, and several guide fossils, typical of certain periods, were identified. The use of radiometric methods, more and more sophisticated, has then allowed geologists to establish very precise absolute ages, with uncertainties not exceeding 1 million years for the most remote ages. But if the intuition on the plurality of extinctions dates back 2 centuries ago, the hypothesis that the events have occurred with some regularity dates back to 1984, when 2 paleontologists at the University of Chicago, David Raup and Jack Sepkoski, published a paper claiming to have identified a statistical periodicity in the mass extinctions occurred during the last 250 million years, with an average time interval between extinction events estimated at 26 million years. Although Raup and Sepkoski could not identify the causes of this presumed periodicity, their idea was that it could be a non-terrestrial connection. One of the first criticisms of this hypothesis was about the alleged periodicity. Was it real, or could it be a mathematical trick? Moreover, why some extinctions were clear and others just mentioned? To this objection, the authors replied that the environmental conditions could be different from one cycle to another. In other words, when the conditions were already of biological stress, the trigger inflicted greater damage to the biosphere. Conversely, when conditions were favorable, the damage was less. Not being known any biological mechanism capable of occurring with a periodicity of 26 million years was therefore logical, especially after the conclusions reached by Alvarez that the origin should be sought outside the Earth's ecosystem, in the solar system, or even in interstellar space. In conclusion, it seemed that every 26 million years, something caused a drastic reduction of living species. The crime perpetrated against dinosaurs was no longer to be considered an isolated case, but was repeated with rigorous punctuality, as if it were a part of a criminal plan coldly premeditated. Despite the skepticism raised by several parties, the scientific community had now moved, and other works followed to address a mystery that was becoming more and more tangled. The asteroid hypothesized by Alvarez was the perfect culprit for the isolated event, but it could no longer be. So now, in light of the new investigations, it was now necessary to hypothesize the existence of a real criminal conspiracy, coordinated and managed at a higher level. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. If it is true that asteroids of a certain type, such as those that travel orbits that approach very close or to even intersect with the Earth's orbit, have all the credentials to cause unpleasant encounters with our planet, there is nothing physically plausible that conditions their visit to specific periods and can give periodicity to their appointments with the Earth. It is necessary to find elsewhere the material executors of the crimes highlighted by Raup and Sepkoski, to look for an area where potential criminals are much more numerous and where external causes can more easily influence their actions. This zone is easily identifiable at the boundaries of our solar system. It is the so-called Oort cloud, a giant sphere of matter composed of billions of comets that gravitate lazily around a distant sun, perpetually waiting for an external event. Even a very small magnitude can drastically change their existence. All it takes is a very small perturbation, and our small and cold ice and dust cluster starts an exciting journey towards the inside of the system, crossing at crazy speed the orbits of the big planets, and sometimes going as far as to touch the huge star that occupies its center. As in an dirty snowball, our comet is about to become perhaps the most striking celestial phenomenon we know, deploying for hundreds of millions of kilometers, their tail and focusing on themselves the attention and sometimes the fear of the men who follow the way on the celestial vault. These apparitions are entirely random and unpredictable events, unless the celestial object is captured and placed in a more restricted orbit, and then periodically recurs to earthly vision, such as the famous case of Halley's Comet. Beautiful apparitions, fleeting, but certainly not dangerous to those which we are accustomed. But what if something with cynical regularity, snatched not sporadically, but at constant intervals, an enormous number of comets from their lazy and distant wanderings, and sent them towards the inner planets. Let's imagine that a certain cause, still to be defined, is able to change course to something like about 1 billion comets. Well, there would be no hope. Our Earth and the other major bodies of the solar system would surely be invested by at least some of these objects, can cause effects quite similar to those discussed earlier about the impact with an asteroid of a few kilometers in diameter. And that is how someone started to ask a question. What if the Sun is not a single star, but a binary star? What if our star was accompanied in its galactic path by a star of small mass placed on a very eccentric orbit? It would be enough that it has an average distance of 88,000 astronomical units and an eccentricity equal to 0.7, which would bring it up to 150,000 AU distant from us in the point of maximum distance, equal to 2.4 light years. So the orbital period of this phantom companion of the Sun would be about 26 million years. During the phase of approach to the Sun, the invisible companion would go to only 26,000 AU, well inside the cometary cloud of Oort, estimated to extend between 10,000 and 40,000 AU. Like the entry of a fox in a henhouse during this close passage that would be repeated precisely every 26 million years or so, our star would create panic, tearing a considerable number of comets for gravitational effect and conveying them to the inner areas of the solar system. The hypothesis about the stellar companion of the Sun was suggested in 1984 by Richard Muller, astrophysicist at UC Berkeley, in an article published in the journal Nature. Funny that, in a completely independent way, the existence of a companion star of the Sun was proposed by two other American astronomers, Andrew Jackson and Daniel Whitmire, in the same issue of the magazine. The hypothesis was very suggestive, as well as revolutionary, but the problems to be solved were gigantic. What should or could be the mass of this star? It was estimated that it could be between 5 and 12 hundredths of the solar mass. In other words, it would be part of that category of extremely small stars called red dwarfs, if not even that of a brown dwarf, even smaller and darker. The phantom star should have a large parallax given its anomalous proximity, and that should make it fairly easy to identify. It would not have, however, an equally remarkable motion because near the aphelion, where it should be at this time, its movement would be extremely slow. Needless to say, as a result of these conjectures, several observational campaigns have been initiated to search for faint celestial objects both inside and outside our solar system. But none of these have been able to identify stars or brown dwarfs compatible with Muller's hypothesis. We must therefore conclude, until proven otherwise, that there is no companion of the Sun, and that therefore our star is condemned, apparently without appeal, to its cosmic solitude. Beyond the fact that the existence of such a star is still far from being proven, other problems have been raised. For example, there are those who refute the dynamic stability of the Sun companion system. Each time the dwarf would reach its aphelion, the gravitational perturbations of nearby stars would be felt violently, and within a few revolutions, the small star would be destined to be torn to the solar attraction. Even existing, Nemesis would be, therefore, a temporary phenomenon in the history of the solar system, destined to disappear in a relatively short time compared to the age of our Sun. The fact that the hypothesis is very risky is, on the other hand, shared by the same scientists who have formulated the theory. With a good dose of humor, Muller and colleagues have rightly proposed on the pages of the journal Nature the name of Nemesis for this star, which is well in common with the Greek goddess of revenge and punishment, but at the same time have also openly declared the fear that it may become a nemesis for themselves. However, it is our detective story has arrived to the last lines, or at least the most important facts have been reported, even if many more pages could still be written about it. The research continues, and it is news of 2020 that of a new important article published in the journal Historical Biology, where the authors completely revised the statistical analysis of Raab and Sepkoski, confirming in practice the periodicity of extinctions at intervals of 27.5 million years. At this time, the small star called Nemesis may be at its maximum distance from the Sun, nearly 2.4 light-years away. This could mean that the next close passage, with its tail of cometary storms and catastrophic impacts, will not occur until 15 million years from now. So we can rest easy.